Okay, welcome to the next video. Today's video we are focusing only on math with Sig Figs. So in a previous video or previous videos we did talk about identifying a number of significant figures, and remember we used the Pacific Atlantic rule where if the decimal is present we count on the Pacific side. We start at the Pacific side and start counting in this direction. If the decimal point is absent, we're starting on the Atlantic side and we're going to start counting our Sig Figs going this way. So if you need a refresher on that, go back to those last couple of videos where we talk about counting the number of Sig Figs, and then once you feel comfortable with that, come back to this video and we'll talk about how to do math with Sig Figs. So just like counting Sig Figs, there are rules when we are doing math with Sig Figs. We need to know what rules to use and in what situations. Now we're really only going to come across two different scenarios, and as long as you know how to use a calculator and know how to count Sig Figs, none of this stuff should be too difficult for you. So let's look at our first situation here. We've got multiplication and division. This is probably going to be the more common scenario that we're going to need to use Sig Figs in class. So we're going to be doing a lot of algebra type questions where we're going to be multiplying, dividing, things like that. So this is the most applicable to our class and what we're going to be doing in class. So for the multiplication division rule, the product or the quotient, or basically just your answer, must have the same number of significant figures as the starting value that has the least number of significant figures. So what we're seeing based on that definition is that our answer relies on what our starting values are. Whatever the least number of significant figures are in our starting values, that's going to tell me how many significant figures my answer needs to have. Okay, so let's just look at an example then. If I'm looking at this first example right here, I see that I have 1.0 multiplied by 235. So the first thing that we need to do is we need to identify the number of significant figures that each of these values has. 1.0, that has 2. Now I'm going to go through this kind of quick because I'm going under the assumption that we're masters at counting Sig Figs now. The second value has 3 Sig Figs. Alright, so we need to compare the number of Sig Figs here. 1.0 has the least number of Sig Figs, so my answer needs to have 2 significant figures. So when I plug this into the calculator, 1.0 times 235 is 235. Now that value has 3 significant figures, but we need to have 2 because this value right here only has 2. So we need to do a little bit of rounding here to get this to 2 significant figures. I know that I want these 2 front numbers to be my Sig Figs, so I'm going to look at this 5 here. Can I round that 3 up from the 5? I think I can, because if it's 5 or higher we tend to round up. So I'm going to round that 3 to a 4, giving me an answer of 240. So that would be my answer to 1.0 times 235. My answer has 2 Sig Figs, 240. Now this ensures that when we're given this math equation, this ensures that we all have the same answer. And that's important when we're comparing data with our group members or with other groups in the science lab. That way we can kind of see what our baseline is for the data that we have. Alright, example number 2. We're going to look at this one now. We have 66 divided by 2. So 66 has 2 Sig Figs, 2 only has 1. So I'm going to be looking for my answer to have 1 significant figure. If you take 66 divided by 2 on your calculator, it comes out to 33. Now I want this to only be 1 Sig Fig. 3. Can I round that 3 up from that 3? No, I cannot. I only want it to be 1 Sig Fig, so my answer is just 30. Alright, so multiplication and division, you want to have the same number of Sig Figs as the least number of significant figures in the question. Alright, that's multiplication and division. Second set of rules, the last one that we need to worry about is addition and subtraction. There will be times here and there where we do addition and subtraction, and we're going to need to be able to use the significant figure rules for these types of questions as well. So the rules for this is that the sum or the difference or your answer must have the same number of decimal places as the starting value that is the least accurate. And what I mean by least accurate is it has the least number of decimal places, because if you have 1 decimal place, you're not measuring as precise as if you were to have 2 decimal places or 3 decimal places. And we looked at this with instruments in the lab and how accurate and precise they are. So we're using that accuracy and precision concept here when we're doing math equations. So we're keeping a note, or keeping mind of how many decimal places these values have. So this first example, let's just get straight to it. 2.00, 2 decimal places here. This has 2. Minus 1.0, this has 1 decimal place. So I want this, my answer, to have 1 decimal place, just like this one does right here. So when you take your calculator, 2.00 minus 1.0, that comes out to 1, and you want that to have 1 decimal place, so that's 1.0. So as long as it has the same number of decimal places as the one with between these two that has the least, you're good to go. Alright, now this second example, 2.33 minus 2.1, or plus 2.1, sorry, 2.33 plus 2.1. So this has 2 decimal places, this has 1, so I want my answer to have 1 decimal place. So if I were to just put this into my calculator, it would tell me that the addition, or the sum of those two values, is 4.43. Oh, I don't know why my stylus isn't working right now. But there's the problem with this is that this isn't the answer that I'm looking for. I want my answer to have 1 decimal place, because over here I only have 1. So I can change this value around. I want it to have 1 decimal place, so this is my number that I'm keeping. Can I round that number up from 3? I cannot. So what that gives me for my final answer is 4.4. And there you go. Has 1 decimal place, just like the least accurate value that you had in your calculation, and your answer is 4.4. Alright, we've seen both instances. We've seen multiplication and division. We've seen addition and subtraction. So now we've got 4 examples here where they're mixed up. What I want you guys to do is pause the video, work on these 4 examples, and when you're ready for the solutions, just press play again and we'll go right through it. Okay? Alright, pause right now. When you're done, we'll look at the solutions. Alright, first one, 6,000 times 1.0. To multiplication, so we want to have the least number of sig figs. This has 1, this has 2. So my answer needs to have 1 sig fig. So if I take 6,000 and multiply it by 1.0, what does that give me? That gives me 6,000. 1 sig fig still. Pretty easy there. Alright, second one, this is division, so we're looking at the least number of sig figs again. This has 4 significant figures, this has 3. So my answer needs to have 3 significant figures. 100 divided by 20 is 5. Now that's only 1 sig fig. So I need to add 2 more zeros after this to give me 3 significant figures. Now that doesn't change the number, doesn't change the value, it just changes how many significant figures I have. 5 is the same as 5.00 because I want to have 3 sig figs. I add those 2 zeros after the decimal. Alright, third one. This is an addition, so we're looking at decimal places here. This has 1 decimal place, this has 2. My answer needs to have 1 decimal place. So the calculator would tell me that my answer is 3.32. But this needs to have 1 decimal place, so I'm going to just get rid of that 2 right there. My solution is 3.3. Almost done. One more. 6.23 minus 3 to subtraction. I want my answer to have no decimal places. Notice how that 3 has no decimal places, so we need our answer to have no decimal places. 6.23 minus 3 comes out to 3.23. I want no decimal places, can't do any rounding from this 2, so my answer is just simply 3.